Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. A regular hexagon lamina of side 30 mm is lying in such a way that one of its sides touches both the reference planes. If the side opposite to the side on which it rests is 45 mm above HP, draw the projections of the lamina. So here, looking at the problem statement, we can understand that the given type of polygon here is a hexagon lamina, and it is having each of its side measuring 30 mm, and the condition is that one of its sides is touching both the reference planes, that is both HP and VP. And also he tells that the side opposite to the side on which it rests is 45 mm above the HP. So its front view will be recorded at a distance of 45 mm from the XY line. So with this data, we need to draw the projections of the lamina. So if you look at the problem statement, you can identify that there is no inclination given with respect to the HP and VP. But however, the only details that is available with us is one of its sides is touching both HP and VP, and the side opposite to the side on which it is resting is at a distance of 45 mm from HP. So with this data, we need to draw the projections of the lamina. So for this, we shall be having the side view of the hexagon lamina so that we can generate the top view. So now we will construct the solution for the problem by selecting the line option from the sketching menu. So let us draw a line of thickness 0.18 mm. So it is a line of any arbitrary length. Now we shall annotate this line as x and y, and also the reference planes as xy, VP and HP. So this is the line xy, the reference line, and the planes as VP and HP. So now we shall draw the first view of the lamina. So this is not visible to the observer. So this is the initial position. So for that, we shall take the projection line of thickness 0.13. So one of its edges is touching both HP and VP. So we shall rest this 30 mm edge here on this condition. So since it is resting on one of its edges, so we shall construct the hexagon in such a way that the edge is touching both VP and HP. So this is the edge, correct? So now we shall draw the hexagon. So 30 mm is the side length, and then the angle of inclination is 60 degrees, followed by 30 mm edge length, and the angle of inclination is 60 into 2. Next, again, the edge length is 30 mm, while the angle of inclination is 60 into 3 or 180 degrees. Next, the edge length is 30 mm and the angle of inclination is 60 into 4, that is 240. And now we shall complete the hexagon lamina by entering the edge length as 30 and the angle of inclination as 60 into 5. So this completes the hexagon lamina. So now we shall annotate this hexagon lamina. So we'll start from this corner. So this is corner A1. Let us call it as corner A1. So since it is the front view, let me call it as A1 dash, followed by this corner B1 dash. Similarly, this is corner C1 dash, and this is corner D1 dash, and this is the corner E1 dash, and next F1 dash. So with this, we have completed the first condition, that is a hexagon lamina resting on one of its edges B1 dash and C1 dash on both VP and HP. So now we shall draw the top view of this lamina. So this is the front view. So how do we draw the top view? We'll just draw the vertical projectors downwards to meet the XY line. So we shall draw the projections from each of the corner, that is D1 dash, from the corner E1 dash to C1 dash, intersect the XY line. Similarly from F1 dash, B1 dash, and from A1 dash. So this corner. Okay, so we shall draw the line and then execute the top view of the lamina. So we will annotate the top view. So this is A1 and this is corner. So the observer is going to look from this direction. So for him, the corner F1 is visible while the corner B1 is not visible. So it is inside the bracket. And here the corner E1 is visible and the corner C1 is not visible, so inside the bracket. And here the corner D1 is visible, so it is outside the bracket. So all this corners is going to indicate the top view of the lamina. So now we have got one more data with us which tells that the side opposite to the side on which it is resting, that is it is resting on the edge b1 c1, and the opposite to that edge is f1 e1. So this is at a height of 45 above hp. So we'll be getting its front view above the hp, so that is in vp will be recording its front view. So we can see that in the side angle projection. So for that, let us draw the x1 y1 line of thickness 0.18 So we shall draw a line of any arbitrary length and annotate this line as x1 y1. This is x1 and y1. So we are going to draw the profile plane. So this is x1 y1 plane. So now we will record the side view of this lamina. So for that we'll select the projection line. So we shall start from the corner a1 dash, so it is going to intersect here. Similarly from this corners e and f, and similarly this is the point of intersection of both the xy line and the x1 y1 line will be having the corners c1 and b1. So now we will annotate this also. So the side view, so the observer is looking from this direction. So for him here the corner E1 double dash is visible first. So let me call this as E1 double dash, E1 double dash, and inside the bracket F1 double dash, because the direction of observation is from the right hand side. So this is the view. So we'll be viewing the corner E1 and the F1 corner will not be visible. Similarly, use the extend to next option and extend this line to meet the corner D. Okay, or it is the projection line from D1 dash itself. So now we will annotate this. So this is um, D1 double dash, inside the bracket A1 double dash, and similarly the point of intersection here is C1 double dash and B1 double dash. Okay, so now this completes the view of the polygon. So that is in the side view. So now we have got one more data which is telling that the edge on which it is resting is at a height of 45 from HP. So we need to have this edge, that is E1 F1 at a height of 45 from the HP. So for that, what we can do is we shall select the offset option and we will offset this line to a distance of 45 from the reference line. So this is how I'm going to get the offset distance. So now let me just use the trim option to trim this part of the offset line. So now we have got this particular line which is at a distance of 45 So the locus line should contain this edge, that is A1 F1. So how do we do that? So for that we shall just use the tangent arc by center point, and then this is the edge which is at a distance of 45 So what we will do is from this point of intersection I am going to measure this height and then cut an arc on this 45 line, the line which is at a distance of 45 from the origin. So now since the side view is visible, let me draw it using a thick line of thickness 0.50 So from the point of intersection, if I'm going to intersect this intersection point, this is the side view, correct? So Let me rename this. Okay, so before I rename all the edges, that is, this is where E1 dash and F1 dash will be visible. So let me just call this point as E double dash, inside the bracket F double dash. And similarly, this edge will be overlapping here. So for that, what I'll do is I'll select the arc by center point from the point of intersection, measure this distance, and then draw an arc. So for this arc and all, use 0.13 mm thickness. So this line from this point of intersection shall intersect the projection lines. Similarly, draw the projections from the point of intersection. So this is from E dash F dash. So intersect the projection lines of E and F. So these are all the new edges where the actual front view of the polygon will be seen. So now we can just annotate this particular point as D double dash inside the bracket A double dash, and this point will be C double dash inside the bracket B double dash. So all the views pertaining to this side view shall be in the RPP itself. So you can just understand that this edge will be overlapping on the same view. So you do not have to draw a separate projection line. So now we will draw the actual front view of the lamina by selecting the line of thickness 0.50. So let us begin from this edge B1 C1 to this point of intersection. This is the end point, and then followed by this end point. This is the intersection point, correct? And this is the point of intersection. And then, okay, so we need to intersect this point here. That is from this corner. So the projection line is here, point of intersection will be here, and then this is the next point. So let me annotate the actual front view. So this is A dash, and this point will be B dash. This is the corner C dash, and this corner is D dash, and this corner is E dash, and this corner is F dash. So this completes the front view of the hexagon lamina. So use the zoom options to check if all the points of intersections are correct. So before we draw the top view, let us just use the leader options to draw the directions of the projection lines. Okay, so choose this leader, change the color to black, click OK from the properties. So this is the first line. So we have drawn the actual side views, all this. This is the actual side view. And then this is from this direction, correct? And then this is from D1 dash and A1 dash. And this is the actual direction. So this is having the lines from either direction overlapping on each other, correct? So now with this, we complete the front view of the particular lamina. So now it is time for us to draw the top view. So this is the top view that is available to us, but before that, let us try to arrive at the top view from this side view. So what we will do is we will draw the 45-degree line from the point of intersection. Draw a line of any arbitrary length, but the angle shall measure 45 degrees. This is the median line. So we know that from the side view, we can just draw the projectors perpendicular down words and then complete the side view. So this is the projection lines. So this is from the corners E and F, and then from this point of intersection intersect the 45-degree line, and then draw a line parallel to the XY line. So from the front view of this particular hexagon, so we will choose the front view. So for that, let us choose this. So you can just see that this is the corner of this, which is lying on the same point. So here also it is C, and then this is again the point B dash, and this is A dash, correct? So now we shall draw the projection lines. So from A it is here, and then projection B is okay, so B will be on the same line, B and C will be on the same line. D will come from this point to this line, so from D and A. Similarly, from E, I'll be having the projection line here, and next the projection line from F, and the side projection line from F. So now we'll complete the top view. So for that, select a continuous line of thickness 0.50 mm. So this is the starting edge, correct? So from point A, from corner A we shall start. So A to B, B to C, C to D, D to corner E, corner E to F, and from F to A. So this completes the top view of the lamina. So we shall just annotate this. This is the corner A. So this is the top view of the original lamina, and this is the top view, that is B. I'll just annotate here. This is corner B, this is corner C, and this is corner D. This is corner F, and this is corner E. So using the trim option, let us just trim the lines that is not required to us. Okay. So with this, we complete the problem statement. We shall indicate the directions of the projection lines in the top view from the side view. Okay. So in order to measure the inclination of this particular lamina with respect to the HP, you can use this. So just measure the inclination. So you can just tell that the lamina is inclined to the HP at an angle of 60 degrees. Okay. So this completes the problem. So to sum up, we have got the hexagon lamina resting on one of its edges, that is BC, such that the edge BC is touching both HP and VP, and also the edge opposite to that edge on which it is resting, that is EF, is at a distance of 45 mm from the HP. So the inclination with respect to the HP is not given, the inclination with respect to the VP is not given, but however the only condition that is given to us is one of its edges is touching both HP and VP, and the edge opposite to that edge on which it is resting is at a distance of 45 mm. So with this data, we have completed the construction of the solution for the problem. So what we did initially, first we have taken the hexagon lamina in such a way that its edge, that is B1 C1, is touching both VP and HP. So B1 C1 dash, B1 dash and C1 dash marks the front view of the lamina. Similarly here, as you can see, B1 C1 edge marks the top view of this edge B1 C1, and from here we have constructed the hexagon in the thin line, and then we have drawn the side view of the lamina. So the side view is going to intersect the points here. So to understand better, we can just place the nomenclature of this particular edges on this line. So this is the point here. So we'll use the point symbol, enter the thickness of the point as the line width. So select 2 mm. So this is the point. Okay, so these marks the points of this side view. So in this reference plane, this is E1 double dash, F1 double dash. The observer is going to look from this direction, and this is D1 double dash, this point. So D1 double dash, and this point is C1 double dash. This is the side view of this particular lamina. So now we are going to draw the side view of the lamina in such a way that one of its edges, that is opposite to the edge on which it is resting, is at a distance of 45 mm. So we will draw the offset line, that is 45 mm from the HP, and then on this we are going to transfer this side view. So how do we do that? From the point of intersection of the x1 y1 line and the xy line, we are going to cut an arc of this length on this 45 mm line. So we will transfer this side view to this 45 mm line, and then this is the inclined position of the lamina with respect to the HP. Only then we are going to tilt this lamina in such a way that its edge is going to be at a height of 45 mm from the HP. Correct? So the actual height, so you can just see that in the initial condition, the actual height is this. Okay, so in order to ensure that the edge opposite to the edge on which it is resting is at a height of 45 mm, we are just tilting this lamina to this position so that it is having its height at a distance of 45 mm. So with this condition, we are going to draw the side view of the lamina. And then after the side view is drawn, we are going to do the reverse position. That is, from the side view, we are going to mark the projection lines in order to get the front view. So we are going to draw a median line of 45 degrees, draw the projection lines, intersect that median line, and from that point of intersection, draw the horizontal projectors, and take the vertical projectors from the visible lamina, that is the actual lamina, that is A dash, B dash, D dash, and draw the top view of the lamina A, B, C, D, E, and F. So mark all the points, all the corners A, B, C, D, E, F from the respective projections from the corners A dash, B dash, C dash, D dash, E dash, and F dash. So with this, we complete the problem statement. Thank you all for watching.